Hello folks, and welcome to this lesson on advanced reactivity. By the end of this lesson, you should be able to use E0 values to determine whether a reaction will happen or not, and use E0 values to determine which reaction will happen in a system. So to start with, let's do a little bit of a recap on the activity series and how you used it to determine whether a reaction would happen or not, based by comparing how more or less reactive different elements are compared to each other. So the type of example problem that you could get is something like, if you take CuSO4 and add it to iron, will you get a reaction or not? Now, if you're going to use the activity series, you would see that iron is above copper. And if you remember, the one that is further up is the one that is more reactive. More reactive means it will become its ionic form. And so, because of that, the iron will go from being the metal to becoming the ionic form. And so the reaction will happen, and you will get copper precipitating out as a solid. So one thing you might have noticed when you were looking at the activity series is that it's not fully obvious how you get the order of everything other than doing things experimentally. Well, to a certain degree, it does happen experimentally, but you do have another tool available to you now, and those are those E0 values, where you look at these half reactions with these ions and so on and so forth. So let's take a look at how these E0 values are, or what those values are, for each of the possible species in these reactions. So we have our copper, we have our iron, but the thing is that with iron, you don't have just the one, there are a few different possibilities. So if we're looking at what reaction would happen, we are going to be taking a look at that first reaction, and this one would happen as it's written, because you're starting with the copper 2 plus ion, so you are starting with the copper 2 plus ion on the left. For your iron, though, you have two possibilities, but it wouldn't be happening in this particular order because you're not starting with iron ions, you're starting with iron metal. So you're actually going to be looking at the reverse of these ones rather than the values as they are written. So if you are looking at the reverse, you're going to be looking at E0 values of positive 0.447 or positive 0.037. So if we're taking a look at what possible E0 value we might get, you're going to be looking at this particular reaction, and then let's look at the second one because it does have a bigger positive value. So if you're looking at the reaction of your copper 2 plus becoming copper metal, and then your iron metal becoming your iron 2 plus ions, then you're going to get an E0 value of that entire reaction of the sum of these two values. Now that total is going to give you a positive E0 value, and because it's a positive E0 value, you are going to have this reaction happen spontaneously. So the conclusion of looking at the E0 values is that this reaction will happen spontaneously. In theory, the reaction where your iron becomes the iron 3 plus ions could also happen because you get a positive number, but it's a smaller positive number, and so this one, where you get the 2 plus ion, is the one that's going to be favorable. So if you're looking at how the activity series is structured, the top elements at the top are going to be better at oxidizing. So they will lose their electrons a lot better, which means that they are better reducing agents. And then the ones at the bottom are better at reducing, and so they are good oxidizing agents. Now the structure of your activity series is going to generally match up with your standard electron potential tables as well. So if we're going to look at another example of whether a reaction may happen spontaneously or not, we can take this one. So we have our aluminum ions, and we have it reacting with nickel metal. So for this, we're going to have to look at those values again for our E0s. And so for our aluminum ions, for the aluminum, we're going to get an E naught value of negative 1.66. For the nickel, we're looking specifically at the 2 plus ion because that's how it's written down. So we get an E naught value of negative 0.26 volts. So if we're looking at the values themselves, we are looking at the aluminum ion becoming the aluminum metal, and so we're looking at this in that direction. But with the nickel, we have to flip this reaction around, and so we are going to look at the nickel metal, because that's the one on the left, becoming the nickel ion, which means when we're doing this, the E naught value becomes positive 0.26. Now, the total E naught for this particular reaction as it's written is going to be negative 1.66 plus positive 0.26, which gives you an overall E naught value for that reaction of negative 1.4. That gives you a negative number, which means that it will not happen spontaneously. Now, if you don't want to do the math on this, you can take a look at where these are in that standard reduction potential table. And aluminum is higher up than nickel, which means that aluminum is better at oxidizing rather than nickel is. And so in this case, you're looking at the reduction of aluminum happening. That's not going to happen as easily, and so therefore this reaction will not happen spontaneously. Now, sometimes the system you're working with, the whole surroundings and everything that's going on in a reaction, sometimes they're simple and they are going to be as easy as the questions that you've seen so far. However, in some cases it's not going to be as easy as that. Sometimes you're going to need to consider the fact that there's water in these solutions. So sometimes it's not going to be what you put in there that's reacting. Sometimes it'll be the water itself that reacts. Sometimes you're working with acidic solutions, which means that you're dealing with H+ or hydronium ions. If you have a basic solution, then you're dealing with hydroxide ions. And then in other cases, you can also have substances that it's possible to have them being oxidized or they can be reduced. So you need to consider both possible reactions to see which one will actually happen. So a question like that could be something like this. Will a redox reaction happen if potassium permanganate is poured into an acidified iron 2 sulfate solution? If so, what is the reaction? So for this, we should cover every possibility that can happen. So you're going to want to take that table of standard reduction potentials and take a look at everything. You want to figure out what possible species that you have. So if we are looking at what we have in here, we know that this is going to be an aqueous system, and so we have water that we have to deal with. We have potassium permanganate, which means we have our potassium ions, and we also have our permanganate ions as well. It's also acidified, so that means we need to take a look at what the hydrogen ions might be able to do. Then we're going to take a look at our iron. It's iron 2+, and then we also have sulfate ions in here as well. So we need to take a look at all of the possible reactions, half reactions that can happen with all of these species. So here are all of the standard reduction potentials that you have available to you that contain these species. Now, you do want to look at all of the reactions, whether you have these particular species on the left or on the right, because you can't just have all the reductions. Something's going to have to be oxidized in a redox reaction. So you have to look at both cases. So the only place that you have permanganate is this reaction, and we can see that permanganate is on the left. So the reduction potential that we're looking for is going to be this as it is. For your F2, there were two possible half reactions, one with the Fe2+ on the left, so this is as is, one with the Fe2+ on the right, so we're actually going to be looking at the reverse reaction, which means that we're looking at an E naught value of negative 0.77. Now it's acidified, so that means we are going to be looking at our H+, which means we have that 0 volt one, regardless of whether this is being oxidized or reduced. We have our sulfate that is on our left, so that means we are looking at this value as it is. With our potassium, it's on our left, so we're looking at this value as is as well. The next two are for water, and your water is on the right, so we're actually looking at an E naught value of negative 1.23. And for this one, we are looking at water as well, but it is as written, and so we have this particular reaction. At the end of the day, you're looking for a redox reaction. And so you need one reduction reaction and one oxidation reaction. And you're going to find one oxidation and one reduction reaction that is going to give you the highest, the most positive E naught value. The highest E naught value that you can get, if it is positive, that means the reaction will happen spontaneously. If no matter what you do, the highest number you get is still negative, then that means no reaction will happen from any combination of what is going on in here. So when we're looking at our reduction reactions, the one that gives us the highest possible E naught value is going to be this first one. So if a redox reaction is going to happen, this is going to be the reduction reaction. Now, out of our two possible oxidation reactions, we want to go with the number or the reaction that will give us the highest overall reduction potential, so E naught value, when you add it with our positive 1.51. And so this is going to be that choice. So when you add those together, you do get a positive number of 0.74 volts. So a reaction will happen when you mix those two things together. And the half reactions for this redox reaction are these two. So now you take your half reactions, you balance them, and you should get an overall reaction of this. And you can't see this because I'm in the way, but that's the last bit of that equation. So this is complex. There's a lot to look for. Practice is going to be really important here. Make sure you try out the practice. Make sure you have me take a look at it to make sure that you're not missing anything. And make sure you do come to me for help if you need it. That's the end of this lesson. I'll see you next time.